Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 8, 2025, about 3 days ago. This paper introduces a modular, interactive system that uses large language models to co-design entire constructed languages, covering phonology, morphosyntax, a lexicon, an orthography, and a concise grammar handbook. The paper is titled IASC, Interactive Agentic System for Conlangs. And as we'll see later, the approach is both creative and surprisingly capable. Beyond the tool itself, the study probes what models know about language structure, with strong results on common patterns, weaker on rare morphologies, and a low resource test, where automatic annotations hurt translation quality, versus an ideal hand annotation reaching about 23.17 on a score called BLEU. Also, the authors shared a GitHub repo. You'll find the full IASC pipeline with Python and shell scripts for generating phonology, morphosyntax, lexicon, orthography, and handbooks, plus prompts, evaluation utilities, sample handbooks, and data. There are controlled experiments, translation workflows, and clear instructions for adding features or new LLM backends. Alright, the previous segment sketched the full pipeline and code release. Table 1 reports how the generated phonotactics match real languages using 3 gram models, listing each model's lowest perplexity pick and whether the true language lands in the top 10. Claude 3.5 Sonnet performs best, hitting the top choice in 4 of 10 cases and placing correctly within the top 10 in 5. Other models trail, and some mismatches arise because Wiktionary uses finer phonetic transcriptions than the systems produce. So, while Table 1 highlighted phonotactic matching, Table 3 defines the hard feature set that stresses the system with rare combinations. The syntax block sets OSV main order, leaves adjective before noun unspecified, and puts possessives before nouns, numerals before nouns, and adpositions after nouns. The morphology block is dense, with ergative and absolutive cases, many prefixes for marking, suffixes for definiteness in person, dual number throughout, and head final relativization with a postpositional relativizer. This mixture forces complex agreement and long affix chains. So, Table 3 stressed the system with rare grammar choices. Table 4 lists the evaluation metrics that score the morphosyntactic transformations. The top group covers existing measures. Translation edit rate counts edits, BLEU averages n-gram precision with a brevity penalty, and CHRF++ mixes character and word F1 scores. The new metrics include stem edit rate for stem order, morphological feature error rate for affix features, morphosyntactic error rate as their weighted blend, and lemma F1 for vocabulary matches. Okay, Table 4 defined the scoring methods. Figure 1 presents morphosyntactic error rates by feature set and model, so it visualizes how hard each grammar was. The chart shows lower errors for Arabic, French, and Welsh, which track more common word orders. Bars spike for Mizo, Turkish, and especially hard, indicating difficult morphology and ordering. The caption notes that GPT-4o Mini was excluded because it failed to follow instructions. Well, Figure 1 highlighted broad difficulty patterns. Table 6 compiles the full results for the morphosyntax module across languages and models. The table lists classic metrics and the new ones, so it shows how stem order and feature errors combine into morphosyntactic error rate. The bottom averages indicate that Claude 3.5 Sonnet achieves the lowest morphosyntactic error rate and the highest lemma F1, while other models trail by several points. Languages with common orders score better, whereas challenging specifications still inflate errors. Alright, Table 6 summarized model scores, and this figure illustrates outputs with complete examples. This figure presents Zashuni translation examples with 2 numbered passages that include English text, an interlinear morphosyntactic gloss, and the final surface form. The upper block shows passage 1 with English text, a morphosyntactic gloss listing features like case and person, and the realized Zashuni line. The lower block repeats the layout for passage 2, which demonstrates consistent handling of narrative sentences and dialogue across the pipeline. Wrapping up, 2 takeaways stand out. The modular, agentic pipeline reliably co-designs full constructed languages, especially with common word orders, and the weak spots concentrate in rare morphologies and lemmatization. The low-resource experiment hints at real translation gains if morphosyntax annotation improves. The open code invites exploration. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.